So when you learned how to add and subtract fractions, you learned both how to do it when they had common or like denominators, and that's really not too bad because the answer has the same denominator as the two fractions and you just add or subtract the numerators. When things got real hairy for you is when you added or subtracted rational expressions that had unlike denominators, meaning you had to find a common denominator before you could add or subtract the rational expressions. Okay, so that's what we're going to do here. Find the common denominator. It functions just like it did with fractions, except now we're going to throw some x's in there. Don't let that freak you out. It's going to be okay. Probably. I don't know. So, take a look at these two fractions. Question number one, do they have the same denominator? They do not. So that means our first goal is to make them have the same denominator. So the denominators we have are 5 and 15. Let's find the lowest common denominator of 5 and 15. Now eventually I want you to be able to find the lowest common denominator without writing out the prime factorization. But for now, let's go ahead and write it out. 5 is really easy. It's 1 times 5. That's pretty simple. 15 is not too bad. Yeah, this is 3 times 5. Or 1 times 3 times 5 if you like. These are all prime numbers though, so I think we're good. The lowest common denominator then is going to be made up of 3 and 5. I could ignore the 1 because multiplying by 1 won't change the answer. So just 3 and 5. So in these two, let's look for 3's. We got a 3 here one time and no 3's here. So 3 occurs at most once. And then the next is 5. We got 1 5 here and we got 1 5 here. So 5 occurs at most one time. So the lowest common denominator is 15. Okay, here's what that tells us. It tells us I need to change these two fractions so that they both have a denominator of 15. Well, good news, this one already has a denominator of 15, so that one's good to go. This guy does not have a denominator of 15, so I need to take the 2x over 5, and I need to make it have a denominator of 15. Yeah, that's exactly right. To get from 5 to 15, I multiply by 3. And if I multiply by 3 on the denominator, I need to multiply by 3 in the numerator. 2x times 3 is 6x. Okay, so I'm going to take this expression here. The 6x over 15 is going to stay the same because it already had a denominator of 15. The 2x over 5 is what's going to change. Instead of 2x over 5, it's now going to be 6x over 15. So 6x over 15 minus 6x over 15. The answer is 0. That's exactly right. Huh? It's not always going to be 0. It just was in this case because the numerators ended up being the same. No, it will not always be 0, I'm sorry to say. All right. You following along with me? Question number 1. Do these have the same denominator? Nope. Gotta find the common one. So I'm going to write out the prime factorizations of 8a and 12a squared. What's 8a? Well, 8 we did a little earlier. 8 is 2 times 2 times 2, or 2 to the third power, times a. What about 12? Six and 2 works, but 6 isn't prime. Let's come over here and do this. 12 is 6 times 2. 2 is a prime number, but 6 isn't. So what are multiples of 6?
2 times 3.
3. So 2 times 3 times 2. That's 12. Now all three of these are prime, so we're good there. So it's 2 times 3, or 2 squared times 3 times a squared. So the lowest common denominator is, I'll start with 2. What's the most number of times we see a 2? Well, it's 3 times here and 2 times here. So the most was 3. Next will be 3. No 3's here, but 1 3 here. So I'll have 1 3. And then what's the most number of a's? 1 time here, 2 times here, so a squared. And when we multiply this all together, 2 to the third power is 8. 8 times 3 is 24, a squared.
Eight times 3 is 24.
Uh-huh. So what this is telling me is I got to rewrite both of these fractions here so that they now have denominators of 24a squared. Unlike the last one, I don't have one that's already done for me. Both of these need to change. So this fraction here, 7 over 8a, I got to multiply by something so that it has a 24a squared denominator. What do I multiply by? 3a. 7 times 3a is 21a. I got to do the same thing with this fraction, 15 over 12a, or 5 over 12a squared. I got to make that have an equivalent fraction with the denominator of 24a squared.
2.
12a squared times 2 is 24a squared. And 5 times 2 is 10. So my new problem is going to be, instead of 7 over 8a, it's going to be 21a over 24a squared plus, not minus, plus, and instead of 5 over 12a squared, it's going to be 10 over 24a squared. Now, do they have the same denominator?
Yes.
Yes. So my answer is going to have 24a squared as the denominator. And the numerator will be?
31.
Why do you hurt me? 21a plus 10a would be 31a.
Right.
21a plus 10 can't be combined because one has an a and one doesn't.
21a plus 10.
It's just 21a plus 10. You can combine them if they're like terms meaning they have the same variable raised to the same power. So like I could combine a, but I could not combine a and a squared. They would have the same variable raised to the same power. Okay? These are a little tricky, but they're not too bad. Which brings me to our next problem. So I do want to find the lowest common denominator. But before I start doing that, I do notice there's one little thing we could do. X squared minus 25 can factor into what?
X minus 5 times x plus 1.
Very good. So, what's the lowest common denominator? Our factors are x minus 5 and x plus 5. Yeah, one of each. Neither one of them appears more than one time. So my lowest common denominator is x minus 5, x plus 5. So I got to rewrite these fractions, these rational expressions, so that they both have denominators of x minus 5, x plus 5. Well, good news. This one already has it. So that one, I don't have to change at all. This one, on the other hand, has to be changed. I have 6 over x plus 5. I need it to have a denominator of x minus 5, x plus 5. So what do I need to multiply by? X minus 5. This is the thing that I multiply by on the bottom, so it's the thing I'm going to multiply by on the top. 6 times x minus 5. Good question. Can you cancel? And the answer is yes, I could cancel these, but if I did, they wouldn't have the same denominator anymore. My goal is to get them to have the same denominator. So yes, you can cancel. I love that you saw that. You should always be looking for things to cancel. Unfortunately, if I cancel now, I'll be back to square one. If I canceled the x minus 5s, I'd be left with 6 over x plus 5, which is where I started. So I got to combine them first and then see if there's anything I can cancel.
And it's supposed to be 12x up top.
Oh, 12x, sorry, right. I mean, how dare you correct the teacher? Shame on you. Do they have the same denominator?
Yes, sir.
Yes. What's the numerator going to be? Yeah, it'll be 12x minus 6 times x minus 5.
So 6x minus, oh, 6x.
That's okay. Makes me a little bit queasy though, because I feel like there's some stuff I can do here.
No, I can cancel?
No, we can't cancel.
Should we
But
multiply the 6x?
yeah, I think, yeah, that's a good idea. So I'm going to leave the denominator alone for now. In the numerator, I've got 12x, and then the negative 6 can be distributed. So minus 6x. And then minus 6 times minus 5 is positive 30. And when I combine those two things, I get 6x plus 30 on the top. And on the bottom, x minus 5, x plus 5. All right, that seems okay. But
What?
I think there's something else I can do. Do you see the other thing that I can do? Oh my gosh, I can factor the top. We should definitely do that. How can you factor this? GCF of 6, leaving me with x plus 5.
No, back to square one.
Well, it's plus
Almost.
minus.
Yeah.
Okay, there we go. We got it factored. Cool. Oh, but
Oh,
look, look, we can cancel.
Oh, now we cancel.
X plus 5, x plus 5,
So
which
we have
leaves
6
me
over
with
X minus 5.
6 on the top and x minus 5 on the bottom.
Oh my lord.
But
Oh, but you know what else we can do?
Nothing.
Nothing. We're done.
How many more problems?
Seriously.
20 minutes and half a page later.
Half
got-
a page.
You guys are a bunch of whiners. We're just going to do like
And
17 more.
is that the real number?
17, yes, it's above 16 but below 18.
But I know, but like, is that the real number?
That's a real number. No, I'm not lying. 17 is a real number. It's how old you'll be in 3 years.
No, 14, not 15.
See, that's just good math. Listen, do you want to know how to do this, or do you want to live the rest of your life in total ignorance at how to add rational expressions with unlike denominators?
I just want to get through college.
You know what?
And
Funny
teach
story
Congress.
is
That's all I
Taylor.
want to do.
Uh-huh,
Today I answered the door at my parents' house.
uh-huh. That's
and
weird.
The guy was going door to door trying to sell something, and he goes, "Is your mom home?"
Uh-huh.
I'm like,
I
"No,
am
I'm
my
like." He's like, "Where's mom and dad?" I was like, "I'm 19."
You're upset because you answered the door at your mom and dad's house and someone asked for your mom?
I know.
I
but
mean,
they
if they wanted
assumed
your
that
mom, it
wasn't
seems
my
like that's the
house.
place they'd go.
That happened to me. My own place. He asked if my parents were there.
Oh, I thought you meant he asked for Addie's mom and dad. Hey, you're right. That'd be
Oh,
weird.
stop.
All right.
I actually had a constable come to my house and ask
Sweet
if
Jesus.
Oh my
Okay.
god.
There's a cop actually asking for directions. Actually, came to
You
my house
guys want
knocking
to
on the door.
finish
I was
doing
like,
math, or everybody want to go around and tell one story about answering the door? What's the lowest common denominator here?
Why? 5.
Y5. Okay.
Whatever.
Yes.
Why?
Y5. Yes. Also known as 5y.
Wi-Fi.
That's not it though.
Is it?
Oh.
These are separate factors.
5y
5y
and y plus 1.
and y plus 1. That's the lowest common denominator.
Cool.
So I got to rewrite both of these fractions so they have denominators of 5y, y plus 1. Now let's see if we can solve this without writing quite so much. Let's see if we can save ourselves some writing. I want you to take a look at this first one right here. The 3 over 5y. I'm just going to rewrite this. 3 over 5y, and I'm going to leave some space over here to the side for the stuff we're going to have to put in. Because the denominator needs to be 5y, y plus 1, and right now my denominator is just 5y. So I'm missing the y plus 1, right? Let's just drop that in there. But if I multiply it on the bottom, I got to also multiply it on the top. Okay? Plus, now I'm going to do the same thing with this. 2 over y plus 1. Now you'll notice I left a little space in front of the y plus 1 because what's going to go there? That's the 5y. If I multiply the bottom by 5y, I got to multiply the top by 5y also. They got the same denominator now. So I've got, on the bottom, 5y, y plus 1. And on the top, 3, y plus 1, plus, and then 2 times 5y is 10y.
So why can't we just distribute the 3y plus 1?
Yeah, we should go ahead and distribute the 3. That's a good idea. So this would be 3y plus 3 plus 10y. And then I can combine the y's, can't I? That'd be 13y plus 3. And on the bottom, 5y, y plus 1. Now this is the point in the problem, once I get everything combined and distributed and whatnot, this is where I would say to myself, okay, can I do any factoring and canceling? And the answer to this problem actually is no, because 13 and 3 are both prime numbers, so there's nothing I can factor out of 13 and 3, so this is the end. Normally, this is where I would look for factoring and canceling, but in this case, there isn't any. We ain't got none.
And you can't you can make it a 5 squared plus 5.
Sure, I could distribute the 5y on the bottom if I wanted to.
So if that ended up an answer, it'd be okay? Like in the...
Sure, written like that is fine. Distributing the 5y is also fine.
So
Those are both correct.
5y squared plus 5?
Plus 5y. 5y squared plus 5y,
yeah.
that would be totally fine.
Okay.
If you just can't handle writing an answer that has parentheses in it, go right ahead.
What I'm thinking, like, if I was to take a test, I would think that would factor more.
It does look like it'll factor more, but it won't because of the 13 and the 3 don't have a common factor.
You know, on the denominator.
Oh,
That distributes.
it'll distribute, but it won't factor. And you don't have to distribute it, but you certainly can.
Because it'll be like 5y squared plus
5y.
But I know that wouldn't be factorable.
Yeah, that wouldn't. You can do it. It wouldn't do anything.
So how do you know when you should and when you can't?
Yeah, that's what I'm saying.
Yeah.
I
believe that's what you
Just because you can doesn't mean that you should. Like here, we can distribute the 5y. There's nothing wrong with doing it. You just won't gain anything by doing it. By gain anything, what I mean is you won't suddenly have something that you can cancel after you distribute that. The only way you can really cancel effectively is by factoring. Since there's nothing left to factor here, I quit. If there was something to factor, I would factor it to see if doing so would let me do some canceling. There's nothing for me to factor.
So don't worry about the distributing, just worry about the factoring.
Yeah, factoring's how you find things to cancel. If you can't cancel anything else, you're done. I mean, you're finished. You're not done. Like, when you cook a turkey in the oven, it's done. When you complete a problem, you are finished. What are we gonna do?
Oh, don't you
We're
do
gonna
that?
do B plus
Multi
three.
multiplier can use automatically put it over B plus 3.
Yeah, so here's the thing. That 2, it's a fraction.
Yeah.
2 over 1.
Yeah, it's 2 over 1.
You're a trickster.
So what is the lowest common denominator of 1 and b plus 3?
1 and B plus 3.
Yeah, it's 1 times b plus 3 or just b plus 3.
Oh.
So I got to change both of these fractions so that they have a denominator of b plus 3. Good news. This one's done. This one does not. But it's really easy. You said, I heard you over there. You're like, can't I just stick a b plus 3 on the bottom? And the answer is, yep. There we go. I multiplied the bottom by b plus 3. 1 multiplied by b plus 3 is b plus 3. But if I multiply the bottom, I got to also multiply the top by b plus 3. And then this one was already good to go.
Would you distribute
I know, I just want to go further with it.
or would you leave it alone?
Yeah, I think we're going to have to distribute right here so that we can combine some stuff. But before we do that, let's add the 2 together. So b plus 3 on the bottom. And on the top, 2b plus 3. Or not 2b plus 3.
God.
Now I'm going to go ahead and distribute that 2. That sounds good.
2B plus 6.
Yep, 2b plus 6 plus b. I'm going to go ahead and combine those. 3b plus 6 over b plus 3. Yes, I can factor the top. There's a greatest common factor of 3. But factoring doesn't help me in this case. I mean, I should factor just to see. But factoring doesn't help me here because when I factor out the 3, there's nothing for me to cancel. I can't cancel the b plus 2 and the b plus 3.
It keeps continuing.
Right. So this answer is fine. And this answer is fine. But ultimately, there's nothing else to do in this problem. There's nothing for me to gain anymore. There's nothing I can cancel.
Got it.
Okay, let's do one more of these nightmares, then we'll move on to something else. When you see the denominator line that long, you know judgment has come.
That fine line.
Oh my God. No, just no. Your fraction jokes are not funny, but your reaction to your fraction jokes is that's pretty great. All right, what do you got?
Factor that one.
Yeah, I can factor both of these, actually. What will this factor into?
X plus 4. X plus 3.
What about this one?
I love her too.
X minus 3 times X plus 3.
How about X
Musical
minus 3?
answers.
So the lowest common denominator is
X. Oh wait.
X plus 3.
x plus 4,
4.
x plus 3,
X minus 3.
and x minus 3.
Why do you have to put all of them in there? I don't understand.
I have 3 factors, x plus 4, x plus 3, and x minus 3.
Okay, got it.
The most any one of them ever occurs is once. So I got to include each one of them one time.
I put SCX instead of LCD.
Oh, good Lord.
I know. Way too fast. Okay.
So
now we gotta
I need to rewrite both of those fractions so that they have x plus 4, x plus 3, and x minus 3 as the denominators. And neither one of them's done, but they're both pretty close. What's this one missing?
X minus 3.
That's missing the x minus 3. So here's what I'm going to do. I'm going to do x plus 4 and the x plus 3 and the 2x. And then I'm just going to put x minus 3 on the bottom and x minus 3 on the top. Great. Plus, let's do the second one. This one was 3x over x plus 3, x minus 3. So which one of the factors is this one missing? This one's missing the x plus 4. Do they have the same denominator now? Yes! X plus 4, x plus 3, x minus 3. And I'm going to try to save myself a little bit of time here, and when I put the numerators together, I'm going to go ahead and distribute them. So I'm going to do 2x times x, that's 2x squared. 2x times negative 3 is minus 6x, plus 3x times x is 3x squared, and 3x times 4 is 12x, equals
6.
the 2x squared and the 3x squared gives me 5x squared. And then the minus 6x and the plus 12x gives me plus 6x. I actually can factor the top, but factoring is not going to help me. I could factor an x out of the top. It would look like this. It won't help me though because factoring that x still doesn't give me anything to
So we
cancel.
can leave it at the top.
Right. This answer is good. This answer is also good. Those are both equally good answers. It's a good habit to get into of go ahead and factor the denominator just to be sure. Or sorry, factor the numerator just to be sure that nothing can cancel with the denominator. It's not a bad habit to get into. But if there's nothing to cancel, there's nothing to cancel. It's not a lot more work to factor out an x, you whiner. Okay? Does anyone have any questions other than who invented this so I can hunt them down? No?